Hello everyone. So today we are going to continue to finish this section. Firstly, let's have a quick review what we did in the last class. So let's review. In the last class, we know how to find S for given A, right? So, and also we also know how to find the B, and the B is similar to A. That means B equals S inverse AS. Okay, and what is B? B is made by lambda 1 to lambda n. Is that like in the diagonal position, it's diagonal matrix with all the eigenvalue in the diagonal position. And what is S? S is made by all the eigenvectors. Okay, all the eigenvector. And this is only for A is not defective. Okay, only when A is not defective is diagonalizable. Today we're going to solve linear system. Now let's take a look at this linear system. y1, y2 prime, which is lambda 1, 0, 0, lambda 2, and here y1, y2. If we have a linear system like this, and what's the meaning of that? That means y1 prime equals 2. If we do the product, so let's see, it's going to be just lambda 1 times y1. y2 prime equals lambda 2, y2. Is that right? And we have two equations. Even we have two equations, but if we look at them individually, there is only one unknown in each equation, and we can solve them easily. Actually, the solution for the y1 should be c1 e to the lambda 1t. y2 should be c2 e to the lambda 2t. And the c1 and c2 are just arbitrary constant because this is general solution. Okay. So think about at the beginning of the class, we make x equals sy, okay? Because when we make x equals sy and we plug into x prime equals ax, right? So we can have a quick review. So sy prime equals a sy, and y prime equals s inverse asy. Also y prime equals b y. Okay, so actually we can solve for y in which linear system? In this linear system, and solve for y, and we can find the solution easily. After that, well, we want to solve this linear system, right? So actually our solution should be x, and then we change this back into, after we solve for y, we times s, and we can get our solution x. I'm going to show you in the example how to do this. Okay, let's take a look at example 3. Use the idea to solve, find all solution to this linear system. So x1 prime equals 6x1 minus x2, x2 prime equals negative x1 plus 2x2. Okay, so we have a linear system like this one, and we know this is x prime equals ax, and here x is vector x1, x2. Now we want to do diagonalization. First step, diagonalization. That means we want to find S, okay, find B. Find S, find B. Let's see how to find S, eigenvectors, how to find B by using eigenvalues, right? So first, definitely here we need to solve for eigenvalue, eigenvectors. So first step, A minus lambda I. And what is A here? A equals 6, negative 1, negative 5, 2. Okay. This equals to 6 minus lambda, negative 1, negative 5, 2 minus lambda. And well, we do this a little bit quick, so we skip the detailed calculation, but this is pretty easy one. Okay. And lambda minus 1, lambda minus 7 equals 0, right? And here we have two eigenvalues, 1 and 7. Next, for each eigenvalue, we need to find the eigenvectors. So eigenvector 5, negative 1, negative 5, 2 minus 1 should be 1. We can easily reduce this into 1, negative 1/5, and the second row should be 0, 0. And write down the solution. Solution should be v vector. Second is the free variable s. First one should be positive 1/5 s. And if we take the 1/5 out, it should be 1/5. Okay. So we need this vector actually. Let's see the next. For lambda equals 7. 6 minus 7, negative 1, negative 1, negative 5. 2 minus 7, negative 5. And reduce into row echelon. And what is the vector v? So we can make this to be the free variable. Here should be negative t. And this equals t, negative 1, 1. Right? So we take this. And we know this is non-defective. Okay? And diagonalizable. And what is s? S is made by what? S is made by the eigenvector. So 1, 5, v1. Next, v2. And what is b? B should be lambda 1, lambda 2. And corresponding to 1, 5, the eigenvalue is 1. And corresponding to v2 should be 7. Like this. Right? Okay. So what that means? So that means y1 equals to, okay, I can write down a little bit more. So that means y1, y2 prime equals b, 1, 0, 0, 7, y1, y2, and solve from here. That means y1 prime equals y1, y2 prime equals 7y2. Solve for y. y1 equals cy e to the lambda 1t. Lambda 1 is 1. It's just 1 times t is e to the t. y2 equals c2 e to the 7t. Right? Here we get the solution y, but this is not our final solution. Our final solution should be s times y. So what is s? 1/5 negative 1, 1 times y, c1 e to the t, c2 e to the 7t. Just do the product. So it should be c1 e to the t minus c2 e to the 7t. That is the first row, right? Second row times that one, so it should be 5 c1 e to the t plus c2 e to the 7t. So this is the solution x1 and x2. Okay? That's the final solution. Or you can write down like x1, x2. Doesn't matter too much. Okay, just use x vector equals that one. Okay, so this is how we solve the linear system. So we can see steps. First, diagonalization, find s and b. And then you can say step 2, solve for y. And what is y? cy e to the lambda 1t, c2 e to the lambda 2t. Okay, and the third step, x equals s times y. And what is s? S made by eigenvectors v1, v2. And times y. Okay, that's the solution of linear system of differential equation. Now let's take a look at the exercise problem. Okay, I will give you the solution here, but you should try this by yourself. First step, find the eigenvalue eigenvectors. But I write down the matrix, and then in the exam, we can get the polynomial. We can always get the polynomial easily. If you get some polynomial, it's very difficult to solve. You must just make some mistake. So you need to redo this polynomial. Usually it should be easy to solve. So we have lambda equals 4 and 8. Next, 4 lambda equals 4. 2, negative 2, negative 2, 2. Reduce into row echelon. Make one free variable as S. Okay, add one eigenvector for lambda equals 8. 6 minus 8, negative 2, negative 2, negative 2, negative 2. 1, 1, 0, 0. So the vector should be, if we make this to be t, so it should be negative t, t. Second eigenvector. So what is our S? 1, 1, negative 1, 1. Okay, write them into column way. And what is B? Made by eigenvalues. So what is Y? Y1, Y2 equals 2. So you can write down C1 e to the 4t, C2 e to the 8t. Right, Y1, Y2. And then what is X? X equals S times Y. Times Y, so I'm going to write down Y here. C1 e to the 4t, C2 e to the 8t. Do the product. C1 e to the 4t minus C2 e to the 8t. Here, C1 e to the 4t plus C2 e to the 8t. Okay, so that's the final solution. We can stop here for this section. This is the application for the eigenvalue eigenvector. So we use eigenvalue eigenvector solve the linear system of differential equation.